So good morning, everybody.
Morning.
Welcome to class. Okay, so
Good morning.
good morning. So I will grade your test. I did a test for all my classes, so which means I have a bunch of copies to do. So I will grade your tests probably, before we're going to meet next time. Okay. And once I grade it, just like with the quiz, I will put the grade on Brightspace and then send you your graded copy to your email in the system. All right. So we're going to finish today. We're going to go ahead and finish this chapter 2, this long chapter 2. You have a lot of sections in it. So we're going to talk about variation. That is not like a big section. It is not. So now we're going to talk about variation. I think this is 2.8. All right, so we're gonna say, basically, we're gonna explore when two variables are proportional, are inversely proportional, basically that, right? When two variables are proportional or when they are inversely proportional. So for instance, if I give this example right here, so this is like the first direct variation. Direct variation. So if I give this example right here, if I have, x, y here, I have 1, that is 3, I have 2, that is, 6, I have 5, that is 15, etc. So -4, that is -12, etc., right? As you can see here, when we divide every value of y by every value of x, we get a fixed number, right? When you divide each value of y on the right by each value of x on the left, you get a fixed number. Here you can see clearly here the variable y here is how much times x. Each x value is multiplied by how much? Each x value is multiplied by
3.
By 3, right? So I can see here the variable y is 3 times the variable x. Okay. Okay, so when that happens, we say that y varies directly as x, or y and x are directly proportional. Okay, you see here we say here y varies directly as x, or we say that y and x are directly proportional. Okay, so, and what that means the two variables, they grow the same way. If one of them increases, the other one will increase the same way. If one of them decreases, the other one will decrease the same way, right? Okay, so that if one of them doubles, the other one will double, okay? Okay, so that is a direct variation. So we say y equal k, and the 3 here, this 3 right here, is what we call the constant of proportionality. This is a constant of proportionality. Okay, so when you say y equal kx, we say that means y varies directly as x, right? Or y varies in the same proportion as x, right? Or y and x are directly proportional. You see what it means? So y and x are directly proportional. Okay, so I think, this concept of proportionality in our daily life, every now and then we have to deal with it, okay? Every now and then we need to deal with it. For instance, we say, okay, I have a medicine, I want to give a medicine to my child, right? But I look at, I look at the proportions, I look at the doses, right? I say, okay, they say, if your child is 20 pounds, give them 5 milliliters, right, of medicine. Okay, so here they say the quantity of medicine is proportional to the weight, right? They say if your child is 20 pounds, give them 5 milliliters. But my child is not 20 pounds. My child is 27 pounds, you see? So I don't want to give them only 20. I mean, I don't want to give them only 5 because it might not have the same effect, right? But at the same time, I don't want to give them like, 10 milliliters because it could be too much, you see? So I can do the small math, okay? As long as I know there is proportionality, right? As long as I know the quantity of medicine should be proportional to the weight. If I know that, then I can do my small math, right? And find how much I should give to my kid, you see? So that is, some type of real life problem that we can have, right? So for instance, if you have this right here, if you have this, let me set up the first example. Okay, so you see, y varies directly as x, which means y and x are directly proportional. When x is 15, y is 9. What is the value of y when x is 6.3? Okay, these are simple problems, right? But let's try to write it in an algebra way, right? So for instance, this phrase right here allows me to write, y equal kx. Okay? By the way, k is a constant of proportionality. I didn't write it here. K is a constant of proportionality. Okay? So this phrase y varies directly as x allows me to write the equation y equal kx, right? Now I need to know k. I need to know what is the constant of proportionality, right? So to know k, I need me a couple of data, right? Which I have here. This couple of data here allows me to find k. And look right here. Well, how much is k right here? When you say y equal kx, how much is k? How to get k by itself?
Dividing.
Divide by how much? Divide both sides by?
X.
By x, right? So we get k, actually k is y divided by x. So I need me one x and one y to find the k, okay? And this allows me to find k. This right here, x equal 15, y equal 9, what I do? I plug in 15 for x, I plug in 9 for y, so I get k equal to what is 9 over 15, right? I mean, it's also, 9 over 15, which is, 3 over 5, which is 0.6. So k is 0.6, all right? If I don't have a couple of data, it's going to be very hard for me to find k. I need me a couple of data. So now that I have y equals, now that I know k now, so I have y equals now 0.6 times x. Okay? 0.6 times x.
That's a 7.
So what is the value of y when x is 6.3? What you do? You just plug in here. So when x is 6.3, y equals 0.6 times 6.3, right? Okay. And then we just do this is how much? 8. Stroke 3.78, right? Okay. So this is an example how to deal with proportionality. So let me give you another one. All right, try to do this one right here. And then you're going to see the answer.
Recording.
All right. What answer you got? Somebody, can you tell me what you did here?
I can.
Yeah, go ahead, please.
I put y equals k times 8. And then I, to get
So y
the,
equal k times what?
I'm sorry, k times x, I'm sorry.
That's k times x, yeah.
Yeah.
Okay.
And then to get the k by itself, I divided both sides by x.
Uh-huh.
So then I filled in the spots
Yep.
with the information. So I put k equals 65 over 80.
Yep, that's right. Uh-huh.
And then I divided 80 into 65.
Uh-huh.
And I got 0.8.
Okay, that's correct.
And then I wrote the second equation is y equals 0.8 times 72.
Exactly, right?
And
Now
then
that you know x, so it's 28 times 72, which is how much?
57.6.
57.6, right?
Mhm.
You see, as again, you know, these proportionality problems right here in our daily life, we come across them like a lot, okay? We just don't pay mind to it, but we can across the proportionality stuff a lot, you see? Basically, you go to a store, you know the price of 3 items, but you wanna buy 5 items. You know, you try to do a little math. Okay, how much money is gonna cost me? You see, etc., etc. This is some type of, you know, proportionality problems. So this is a direct variation. Now another variation is the inverse variation. The inverse variation, as the name indicates, it means when one of them increases, the other one decreases, right? For instance, we say, just an example right here, xy. Say 1, 3, 2, right? Okay, etc., etc. So 20, you see here, what happens here? First of all, as x goes bigger, what y is doing?
Y
What's
is
y
getting
is
smaller
doing?
in increments.
Y is getting smaller, right? About the same way, you see, x goes from 1 to 2, y goes down from 3 to 1.5, right? When x is doubling, y is divided by 2, right? So this is the inverse variation. Something gets, one of them gets bigger, the other one gets smaller. It's the same way, right? Okay, so that is the inverse variation. Look right here. Y equals what? When you look at this, when you multiply, what happens here when you multiply them? When you multiply each one, now it's not the division. What is 1 times 3? It's 3, right? What is 2 times 1.5? Is also 3. You can take your calculator. What is 10 times 0.3? Is 3, right? What is 20 times 0.15? Is also 3. In this case now, it's not the division that is a constant number, it's a multiplication that is a constant number. And when you look at this, I can say here, y equal to 3 divided by x. You see, that is what I get here. When I say 3 divided by x, 3 divided by 1 is 3. 3 divided by 2 is 1.5. 3 divided by 10 is 0.3. 3 divided by 20 is 0.15, right? Y equals 3 over x, all right? So that is inverse variation. You see, when one of them goes up, the other one goes down, right? And vice versa, okay? Inverse variation. And here, the 3 here, which is a K, happens to be X times Y, right? So X times Y is constant, is 3. So when you say, we say Y, when you say Y equals K over X, we say that it means Y varies inversely as X, or Y and X are inversely proportional. Okay, Y and X are inversely proportional. In this case here, the K happens to be Y times X. You see, when we multiply X on both sides here, the X cancel out, so we get K here is XY. Okay, that is the inverse variation. The K here is XY. All right. So, for instance, let's pick another example right here. Y varies inversely as X, okay? When X is 65, Y is 9, right? When X is 65, Y is 9. So when I write this, right, when I see this allows me to write Y equals K over X, okay? Now, we said K is always the product of X and Y. K is X times Y. Okay. Now I need me a couple of data. I need me a couple of data to be able to find K. So X, Y. You see? So K is 65 times 9, which is 540 plus 45, 585. Right? Okay. So now that I know my K now, I come back here, I say Y equal actually 585 divided by X. So whenever you give me X, I put X here. It's going to be 585 divided by 50. It's 11 point something, right? 585 divided by 50 is 11.7. Okay, so that is the inverse variation. You see here, when X went down, what happened to Y? Y went up. You see, X went down from 65 to 50. Y went up from 9 to 11.7 in the same way, in the same proportions, right? So that is the inverse proportionality. So now let me give another one. And then you try to do it. All right, so go ahead, do this one. All right. Okay, so can somebody tell us the steps here they did? Can somebody tell us the steps they did to find the value of y? Annette, do you want to do it?
I can try.
Okay, go ahead, please.
So I just trying to keep myself organized. I just wrote y equals k over x,
Yep, y equal
Which-
k over x.
which would be 5 equals k over 12.
That is correct. So 5 here and 12 here. So 5 is equal to k over 12, right? So how much is k then?
So k would be 60.
Yep. So for everybody to know how to get 60, we multiply by 12 on both sides, right?
Right?
When you do that, we get k equals 60. That is absolutely correct. So now that you have k equals 60, you have y equal to 60 over x, right? Now what you do next, the last step now to get y?
You just fill in the 4, x equals 4, so y equals 60 over 4.
Exactly, thank you. So now you just put 4 here, so you get y equals 60 over 4, which is 15. Thank you. Okay,
Well.
so that is, the inverse variation. In the inverse variation, the k is always a product of x and y. In the direct variation, the k is the division of y by x, right? Okay, it's very important to find k, and there is no way we find k until we get a couple of data, right? We always need a couple of data, one x and one y. If you know one x and one y, then we know we will find k. Okay, so now when we say the third variation is, when you say z is equal to kxy, when you say z is equal to kxy, you see here we have three variables. We're going to use another terminology. We say z is jointly proportional to x and y. Okay? When you say z is equal to kx over y, can you translate this formula into a sentence? What can we say?
I didn't hear what you said.
So when you write this one, z equal to kx over y, right? Can you translate this in a sentence like, the one? What can we say here about the variable z, x, y? The k is a number, right? K is a known number. So
Would it be inversely proportional then?
inversely proportional to what variable? Z is inversely proportional to, Z is inversely proportional to what variable? To what? To what variable? What is, you see, inverse proportionality? Inverse proportionality to y, exactly. Okay. Inverse proportionality means if one is up, the other one is down, right?
Okay.
Z is inversely proportional to y, but it is directly proportional to what? To x, you see? Z is directly proportional to x and inversely proportional to y. Okay, what it tells, so it tells me Z is directly proportional to x and inversely proportional to y, right? Just in case, you see that, you see something like that, okay? So let's see a couple of word problems and then we're gonna close this section right here. Okay, so let's see a couple of word problems. So when we say word problems, we don't like them, but it doesn't mean they are very hard, okay? For instance, here we say the time that it takes to fill a swimming pool with water varies directly as the depth of the pool. You see, a swimming pool manufacturer, etc., claims that a backyard swimming pool that is 4 feet deep can be filled with water in 3 hours, right? If this is true, how long would it take to fill a pool that is 8 feet deep? Believe it or not, this is exactly the same math problem as this one. Exactly, you see? This was what I just read, and this is exactly the same problem. But when we see a lot of sentences, it's kind of mess up our, oh, this is very hard, etc., etc. It's not at all. Okay? So what you're going to do here is, first of all, we're going to do the variables. You see, I don't have variables yet, right? I don't have variables yet. Tell me, what are the 2 variables involved here? When you read, for instance, the time it takes to fill a swimming pool with water varies directly as the depth of the pool. What are the 2 variables here you see, you read?
Time and depth.
Exactly, thank you. You see the time, okay, and the depth. These are the 2 variables. Now you can name them, you can name one of them X, the other one Y, or you can choose actually the initials, right? Because the initials will tell you what the variable represents, right? Okay? Or you can call them XY. So what do you prefer, XY or, T and D?
XY.
XY.
Stick with what we're doing.
Okay, so let's call them X and Y, right? So we say X is the time, right? And Y is the depth. Now we say varies directly right here. This varies directly allows you to write what equation? Y equal what?
X times
KX,
Y.
right? It allows you to write Y equals KX because it says varies directly, right? Now it says now look at the next sentence now. Okay? It says what? To fill a pool that is 4 feet deep. The 4 feet will be the value of what variables, the X or the Y? The 4 feet will be the value of what variables, the X or the Y?
Y.
So why? Because remember, Y represents the depth. So the 4 feet here, and then the X is what? How long we need to fill the 4 feet deep pool? We need 3 hours, right? So you have 4 is equal to K times 3. You divide by 3, you divide by 3, so you get K equal to 4 over 3. All right? So now that you know that, so we say, how long would it take to fill a pool that is 8 feet deep now? So we have Y is equal to 4 over 3 times X. All right? So now here, to answer to the question, 8 feet represents the value of what variables? Y and the X. 8 feet represent what?
X.
No, 8 feet represent, remember, X is the time.
Oh, okay.
You see, 8 feet represent what? The
depth.
The depth. You see why I suggested to call them T and D? Do you see why? Because then this is more telling, right? XY is not telling. XY is XY. But when you say T, you know it's time. When you say D, you know it's the depth, right? So now you say 8 is equal to 4 over 3 times X. Now, if you have a fraction next to a variable, if you have a fraction next to a variable and you want to cancel that fraction, what you do? Remember the algebra, what you do? You have to multiply both sides by what?
Common
I want-
denominator.
I want to cancel that fraction 4/3, which is next to x. What I do, I multiply by somebody.
3.
I need to multiply by what fraction to make this one go away? What fraction will cancel the fraction 4/3?
3/4.
3/4.
Exactly, thank you very much. The reciprocal, 3/4. Okay, so this fraction will cancel this one. So we get x equal, you see why I didn't replace 4/3 by a number? Can somebody tell me why I didn't replace 4/3 by a decimal? I left it 4/3. Can somebody tell me the reason? Because 4/3 is 1.33333333, right? You see, I don't have to replace it by 1.3. 4/3 is just 4/3, right? Okay, just was the reason we left it like that. Okay, so now it's going to be 8 times 24 divided by 4 is going to be x equals 6 hours. Okay, so you see this word problem right here is exactly the same stuff we solved before. It is the only difference here, we have sentences, we have a context, right? You see, the one we solved before, there was no context. It was y varies directly as x, if, etc., etc. But this one has a context. You know, sometimes, you know, we confuse, you know, we conflate between the context and how hard is the problem. It's not, you see? All right. So let me see if we have another one word problem and then you try to do it. And again, you know, you don't let yourself be, you know, confused by the context, etc., etc. We really don't need, you know, right here. You see, for instance, here, we don't need to know the whole physics stuff. It is about physics, but we don't need to know the whole physics stuff. We just read. We have some keywords that are important. Some keywords. First, I identify the variables. What are the variables that are here? And second, I see, is it a direct variation or is it an inverse variation? That's it. Go ahead. All right, so tell me, what are the two variables that you see? Obviously, what are they? What are the two variables here?
Force and distance.
Thank you. Force and distance, right? Is it, I mean, I think it's pretty much clear, right? You see, I see F and I see F and I see X, right? F here is one force, one variable, K is, X is the other variable, right? So, and then it says it varies directly. So now I have the choice, I can say F is equal to K times X, you see? In this case here, I have to use F because they give me F. They told me the variable is called F, okay? I have to keep F. That is, a famous, Newton law or something like that, okay, in physics. Okay, so now, if in 24 Newton is a unit of the force, right? 24, force stretches a spring by 20 centimeters, right? 24 here is a value for F or for X. 24 here is a value for F, for the force, or for the distance. For F, right? This is 24. And then the X is, the distance is 20. So I have 24 is equal to 20, K times, I have 24 is equal to K times 20. I divide by 20 on both sides, right? So I get K equal to 1.2, right? So I have F is 1.2 times X. You see, that is my formula. Now determine the force needed to stretch the spring by 36 centimeters, right? I plug in 36 for X or for F?
X.
For X, exactly. So I plug in 36 for, yes, I have F is equal to 1.2 times 36, which is
43.
Which is 43.2 Newton. Okay. You see, these are word problems, of course, but if you look beyond the phrasing, beyond everything, you have to deal exactly with the same problem we dealt with before, right? Okay, so that is this small section variation, do we ask about this a lot in the test? No, I don't, okay. So, but we need to go over it. So now chapter 2 is finished, right? We're gonna start chapter 3, which is, I have to say, which is different from chapter 1, chapter 2. Chapter 3 is different, okay? It's completely different. So it is radical expressions and equations. That is chapter 3. And of course here, 3.1 will be square roots. So we're gonna learn what is the square root of a number, all right? So 3.1, if you know it, it's gonna be just like a review for you. 3.1 will be square root. Okay, let's see an example. Let's see an example right here. We say, for instance, 3 squared is equal 9, right? So we say 9 is the square of 3, right? Okay. 9, obviously 9 is a square of 3. What is the square root? The square root tells you 3 is the square root of 9. Okay. 3 is a principal square root of 9. All right. And the 3 has to be positive, of course. Okay. That is the definition of square root. When we say what is the square root of 9, when we ask what is the square root of 9, we are asking what number we square to get 9. That's what square root means, okay, if you know that number. All right. So for instance, if I ask you, what is the square root of 25? What's going to be your answer? What you going to answer me? What is the square root of 25?
5.
Is 5, right? What number we square to get 5? I mean, 25 is 5, okay? So, and we note here, we write 3 is a square root of 9. You see, when you write this, the two numbers inside have to be positive. 3 have to be positive. 9 have to be positive, right? Both of them have to be positive. And 9 have to be positive. Okay? That is when we write 3 is equal to square root of 9. All right? So that is the definition of square root. The square root is basically the inverse operation of square. You see, when you square something, the inverse of that is a square root, okay? So let me write the definition of what you call principal square root. Okay? So here we have to insist on some words here. First of all, the word principal right here. You see, when square b square is a. So we say b is a principal square root of a. But in a case, both numbers are not negative. A is non-negative and b is also non-negative. Okay? So why we do this slight distinction? Why? For this reason. If you come back to 3, I have 3 squared is equal to 9, right? But think about it. Do you have another number that when you square you get also 9? Or is it only 3? Think about it. Is there another number when you square that number you get also 9?
-3.
Thank you very much. -3, right? Okay. So -3 is also, when you square -3, we also get 9, right? -3 squared, you can check with your calculator, is also 9, right? But -3 is not positive. You see, -3 is not positive. So when somebody asks you what is the square root of 9, you don't say -3, you just say +3, okay? The square root has to be positive by definition, right? Is a positive number, okay? The principal square root has to be positive. But if you ask the question that way, what are the numbers when you square them you get 9? You have 2 numbers, you have 3, you have -3, right? But the radical sign, that square root sign, belongs only to the positive number, okay? Do you agree with that? The radical sign, this is a radical sign. We call this a radical sign. This is a radical symbol, right? Or symbol. Okay, so, and the number inside is called the radicand. You see, this number inside is called the radicand. Okay, so when you say square root, your outcome should always be a positive number only. Okay, so what is the square root of 36? What do you think?
6.
It's 6. Why? Because 6 squared is 36, right? What is the square root of 64? Everybody, what is the square root of 64?
8.
Is 8. Again, why? Because 8 squared is 64, right? What is the square root of 121?
11.
11, right? Thank you. Why? Because 11 squared is 121, right? All of them numbers are positive. You see, the number inside is positive, the number outside is positive. Sometimes we write square root of 36 with nothing here. Sometimes in some calculators, you can see square root and we put 2 here, right? Which is the same thing, okay? Now, if by default, if you don't put no number, it is square root. We're talking about the square root by default, if you don't put no number on top of it, okay? All right, so now, if I tell you, how much is the square root of 5? What do you tell me? What do you tell me?
There's no square.
It is, you see, a square of 5, do we know it? Do we know exactly how much is square of 5?
No.
We don't know exactly how much is square of 5, but we don't say it doesn't exist. It does exist. It's just not on an exact number, okay? That is why, unless somebody asks you to write what is the approximative value, unless that, you're gonna keep it square of 5, right? You see, if I see square of 9, when I see square root of 9, I know it is 3, right? So I write 3. If I see square root of 16, I know it is 4, I write 4, okay? When I see square of 100, I know it is 10, I write 10. But when I see square of 5, I don't know how much it is, I leave it as is, right? But it does exist, okay? Now, if you wanna know what is the approximative value of that, you get your calculator out, right? You see, I got my calculator out. So in my calculator, I have a square root sign right here, you see? So I write 5, a square root of 5 is about 2. You see the decimal number never stops, right? This never stops, right? So the square root of 5 is about how much? It is about 2 point, et cetera, et cetera. It has a lot, a lot of decimals, right? Is about this. That is about square root of 5. And the decimal numbers, they will never stop, right? It is an irrational number, okay? You see, so square root of 5 is about this. So square root of 5 is, this is about square root of 5, right? But any number that is a positive number has a square root, right? Whether it is an exact number or sometimes it is not an exact number, but any number, if they are positive, then they have. So now, if I want to do squares of a negative number, look what is going to happen. Let me get my calculator out, right? If I want to do the squares of negative 16, I have 16 here, I put negative, and I put square root. You see what it said? Invalid input, right? Square root of a negative number is not a real number, okay? Square root of a negative number is not a real number. For now, the only numbers we're going to put inside the square root, the only numbers we're going to put inside the square root will be positive for now, right? Okay. What is the square root of 0? What do you think? How much square root of 0?
0.
Is 0 itself, right? What is square root of 1?
1.
Is 1 itself, right? Okay. So that is a square root, that is a radical stuff. So now we're going to see, after we saw the square root, right? We're going to see how to simplify square roots. We have the first property right here. If A and B are non-negative, then we have square root of AB is equal to square root of A, or the other way around, right? Okay, so basically this example tells you if you have, when you multiply two square roots, you can put them together. That is a very, very important property of square roots. Okay, that is a very important property of square roots. When you multiply them, you can put them actually together. All right, so for instance, when I say, somebody asked me to simplify this. Square root of okay, for instance, do I know each one of them exactly? Are these two square root exact numbers? Are they? Are they exact numbers? They are not, right? Square root of 2 is not an exact number. Square root of 8 is not an exact number, right? But what the rule above allows me to do? It allows me to put them under the same umbrella, right? Under the same square root. If it is a multiplication, by the way, you see? If it is addition, we don't do that, okay? If it is a multiplication, so this rule allows me to do, this is actually square root of 2 times 8, you see? Okay? And which happens to be what? Square root of what number? What is 2 times 8? 16, right?
Yes,
And what is
4?
Is going to be 4. You see, by applying this rule here, it allowed me to simplify something, otherwise it would be very hard to simplify, okay? This rule allowed me to do that. All right, so, and it can go the other way around. You can ask you to simplify square root of 18. Simplify. Now we're going to the other way around, square root of 18. The best we can, you see? Square root of 18 is not an exact number, right? because 18 is not a perfect square. By the way, everybody knows the perfect squares between 1 and 100. What are the perfect squares? This start with 0, and then we have 1. What is the next perfect square?
9.
Before 9, what is the next one?
Oh,
After
4.
1? 4, and then 9, and then
16,
16,
25,
25,
36.
36, 49, right? 64, 81, 100, 121, 144, etc., right? These are the perfect squares, okay? You see, 18 is not one of them. 18 is not a perfect square. But you're asking me to simplify. Can I break down 18 with a perfect square as a multiplication of a perfect square and another number? Can I do that? Is that possible? If I think about it, 18 is what? What times what?
9 times 2.
9 times 2. Why we don't say 18 is 3 times 8? I mean 3 times 6. Why we don't use 3 times 6?
Because neither 3 or 6 is a perfect square.
Thank you very much. You see, we have 18 is 3 times 6, but we don't take this one. Is 9 times 2, we're going to take this one, right? Because at least one of them is a perfect square. You see, so we're going to say 18 happens to be 9 times 2. Now, what the rule allows me to do? The rule allows me to split, right? It's going to be squares of 9 times squares of 2, right? And now, how much is squares of 9? It's 3, going to be 3 square root of 2. Okay. So when we say simplify root of 18, this is what you mean by that. My answer is simplified. I can see that because now the number inside the radical is smaller than 18, right? Okay, so I broke it down that way. So that is how we simplify. So you're going to have to do that. We will do that. So simplify square root of 75. Go ahead. Meanwhile, everybody, please write your name for the attendance. All right, so tell me, what is the best way to break down 75 so it can help us?
25 and 3, the square root of 25 and the square root of 3.
Exactly, 25 and 3. So 25 and 3. That is the best way to break down 75, right? Because 25 is a perfect square. So it's going to be square root of 25 times 3. Now the 25 is a perfect square. When we get him out, it becomes a 5. It's going to be 5 square root of 3. Okay, so you know, I read a question about the combined variation. Okay, so I do not want to take a lot of time on about that. It's like a joint variation. Okay, combined variation is when you have more than two. If you have three variables, four variables, etc., etc. So sometimes we don't spend a lot of time on something that is not very relevant. But it is like a joint. It is a joint variation. It is the same thing, right? Combined variation, joint variation. All right. So how are you going to simplify square root of 72? Square root of 8. All right. So what is the best way to break down 72?
8 and 9.
8 and 9, right? Okay, 8 and 9 is good for a first step, right? Do we have, if you want to do it at once, right? Only one step, what can we do? Can we find better than 8 and 9? Can you find a little bit better than that? Somebody? All of you did 8 and 9, all of you. If you do 8 and 9, then that's going to be one step, right? But we have a better combination than 8 and 9, right? But we can do that. You see, you can see squares of 9, 8. So it's going to be 3 squares of 8, and then we have to keep going because 8 is 4 and 2, right? Okay, it's going to be 3, you see, times 2 times squares of 2, which is 6 and 2. But there is one step thing is instead of 8 and 9, we can say 36 and 2. All right, 36 and 2, and then square of 36 is 6 root of 2. All right. And of course, square of 8 is 4 and 2. So 2, so 4 comes will be 2. All right. So before we start, our next topic, that's going to be, how to simplify some of the stuff. So we're going to stop right here. Meanwhile, like I said, I will grade your papers, in the next 1, 2, 3 days, and then put it on Brightspace. All right. So we're going to stop right here. Anybody has a question about what we did today?
Actually, I have a question about the homework practice problems. Modules 1 and 2 are due on Sunday, correct?
Okay, let me double check. That is.
Yeah, I was wondering that
is-
too. All those are due the 10th, I think.
Yeah,
I think it was
10th.
just module 1 and 2. The modules after that are due sometime in November.
Yep. I just, chapter 1, chapter 2 are due the 10th, right? Okay, and then the next ones, they are not due because, I did set it up this way, just to give you a chance to do the homework, right? For those who want to do the homework. But like I said, the efficient way to do the homework, if you want homework to help you out, to help you reviewing, is to do it in the same pace we do in classroom. That is the best way. You don't care about the due date, right? If you have until December to do something, if you want it to help you, don't wait until December, because by then the topic is off, right? You see, if you wanted to help you, but why I did it this way, because just, you know, if for me, like to help some people, you know, who maybe, because I know every one of you, every one of you will need the points, the homework points, every single one. If you are A students, you still want to need the 10% of the homework. If you are B students, you're going to need them. If you are
How many
struggling,
points is the homework worth?
I think it's 11%, I think.
Got it.
Right? So everybody will need that. That is why I gave this, you know, I group them chapter by chapters. 1, 2, you see, after the test, you know, we just did the test and now we're done with 1 and 2. Then 3 and 4, I group them, etc., etc. But if you want them to help you, do, for instance, today we did 3.1. If you go home, you have some free time, try to start 3.1. You see, that's how you're going to help you. Okay, don't let until like November to do 3.1. All right, everybody. All right, so homework do help, you know, the points, you will need the points. All right, so everybody have a good week and see you next Tuesday.
You too. Thank you.
Thank you.
Just,
Yes.
when did you say you were gonna
Everybody.
grade the test?
Yeah, I said, you know, I did test for all my classes, like I have 5 of them, 5, 6.
Oh, my goodness.
So that
Okay.
is, I have a bunch of grades to do, but
Okay.
by the time we're gonna meet next time, you're gonna see your grade already. Okay, so probably like in the next couple of days, I will grade them.
Okay, just
All right.
wondering. Thank you.
Yep.
Have a good day.
Thank you.
Bye.
Bye.
Bye.